Have you even really thought about what's inside a bag of cement? I mean, it seems so simple, right? It's just a gray powder. But that powder, it holds this incredibly complex global story. A story about different rules, different tests, and a huge debate about what strength even means. So, let's get into it.
So, let me ask you this. If you go and buy a bag of high-strength cement in Mumbai, is it basically the same thing as a high-strength bag you'd find in Berlin? You might think so, but the answer is a hard no. And the why behind that? Well, that reveals a fascinating divide in the entire world of construction.
At the very heart of this whole thing are two completely different rule books. You've got India, which uses the Bureau of Indian Standards, or BIS, and then you have Europe, which follows the European Norms, or EN. Now, they're both trying to do the same thing, define cement quality, but as you're about to see, they go about it in fundamentally different ways.
All right, so first, let's just take a moment to appreciate how surprisingly complicated the world of cement really is. You see, around the globe, a cement's grade, or its class, that number on the bag, it's not a universal language. What one country calls a 53 grade could mean something totally different somewhere else. And for huge, international construction projects, this isn't just a little confusing. It's a massive headache. It can affect everything from the design of a skyscraper to its ultimate safety.
And hey, don't just take my word for it. As one professor from IIT Madras put it, the world of cement testing is, and I quote, very complicated. And you know what the biggest point of complication is? It all comes down to one simple, everyday ingredient: water.
Which brings us to the main event, the Strength Test Showdown. This is where we see exactly how and why India and Europe go their separate ways.
So the Indian BIS standard is built around this key idea called normal consistency. Basically, the whole goal is to find the absolute minimum amount of water you need to perfectly wet every single particle of cement and get a good workable paste. It's a flexible approach because every batch of cement is a little different.
Let's think about this like you're a baker, okay? The Indian method is like saying, okay, measure out your flour, then add just enough water until you get that perfect dough consistency, you know? Some flour might need a little more, some a little less. The goal is to get the perfect paste every single time.
But now, let's look at the European method. This is like a baker with a super strict recipe. You measure your flour, but then you have to add a fixed amount of water, a 0.5 water to cement ratio, no matter what. It's standardized, sure, but it means you're not necessarily getting the best possible paste for that specific cement.
And this chart right here, it shows you everything you need to know. The Indian test, using that normal consistency method, usually ends up with a water-to-cement ratio of about 0.4. The European test, it's locked in at 0.5. Now, more water generally means lower strength, so you can probably see where this is going.
And here it is, the big aha moment. Because the European test uses more water, the cement just seems weaker in the test results. This means that a high-strength Indian 53-grade cement, if you test it using European rules, suddenly looks like their lower 42.5 grade. It's the same cement. The cement isn't different, the test is.
But hold on, the differences don't stop at the testing, not even close. The European system has a totally different philosophy about what actually goes into a bag of cement. It's less like one single product and more like a giant Lego set.
So the European system has these 5 main families of cement, from your basic CEMI all the way to more complex blends. But honestly, the real magic isn't just about these 5 types. It's about how you can mix and match them, giving engineers some incredible flexibility.
The secret sauce here is something called composite cement. The EN system lets manufacturers blend the main ingredient, called clinker, with all sorts of different additives, things like fly ash from power plants or slag from making steel, to create these super specialized products.
Just look at this example of a composite cement. It's not one pure thing. It's a precise recipe, a cocktail if you will. You've got your core clinker, but it's blended with very specific amounts of fly ash and limestone. Each one of those ingredients is in there for a reason, all working together to get a specific result.
And this whole system creates these incredibly detailed codes. I know, a code like this looks like total alphabet soup at first glance, but every single letter and number tells an engineer exactly what's inside: the blend, the percentages, the strength class. It's basically a complete DNA profile for that specific bag of cement. So why go through all this trouble? Well, because these custom blends let engineers create tailor-made cements. You need something to build a structure in salt water? There's a blend for that. You need something with crazy long-term durability for a massive bridge? There's a blend for that too.
It's all about precision engineering for the specific job.
So with all this fragmentation and confusion, it's really no surprise that there's a big push in the industry for a single global standard. But what would that even look like?
Well, the big idea on the table is to create one unified rulebook under the International Standards Organization, or ISO. And maybe not surprisingly, this proposed global standard is very, very heavily based on that flexible, blend-focused European system we just talked about.
And of course, this raises a massive, multi-billion-dollar question for one of the world's biggest cement producers. What would it actually mean for the Indian industry to adopt this new European-style standard?
Well, the challenges are huge. First off, like we saw, Indian cement grades would suddenly look lower on paper, and that's a massive marketing problem. Producers would have to completely rethink how they manufacture and grind their cement to hit the new targets under the new tests. It would take a monumental industry-wide effort of testing and reevaluation. But here's the thing. Whether the world moves to one standard or just keeps going with many, one trend is absolutely clear. The future of cement is not just generic gray powder. It's in these highly specialized designer composite blends that are engineered for very specific high-performance jobs. So what's the bottom line here? It's that the simple number on a bag of cement is so much more than just a number. It tells this deep, fascinating story about chemistry, engineering, and the totally different ways we define strength, quality, and performance all around the world.
And that leaves us with one last really big question to think about. As we build our future, our cities, our bridges, our homes, are we going to build it using one global language for our most essential material, or will we continue to build it with many?